Thank you for joining this lesson. We're going to discuss three-dimensional geometry. Remember to subscribe to this channel and to also share the link with friends. Figure below is a pyramid on a rectangular base. PQ equals to 16 centimeters, QR 12 centimeters, and VP 13 centimeters. Find the length QS. So the length QS is the length from this point up to this point. There are already some provided lengths and enough information to help us. Because the base is a rectangle, you can see that there is a right angle at P on the base, such that now considering the right angle there and PS being 12, now that is the width of the rectangle, then we can use Pythagoras theorem, whereby we will take 16 squared and we add 12 squared, then we obtain square root. That will give us the length QS. So I will take 16 squared, then I add 12 squared, then I take square root of this now, and the answer is exactly 20 centimeters. The next is the height of the pyramid to one decimal place. The height of this pyramid to one decimal place. For us to get the height, we can consider a few things. Remember, we are having this one as 20, so we can take OQ to be 10, and OQ being 10, and at the same time we have 13 centimeters at this point. Then we can use all the slanting edges are equal to 13. So we can use 13 and 10 for us to get the height VO. Therefore, we need 13 squared minus 10 squared because the right angle is at this point now. So we'll need 13 squared minus 10 squared, then we obtain square root. Again, Pythagoras theorem. So 13 squared minus 10 squared, then I obtain the square root. This is a 8.3 centimeters. Remember, it should be to one decimal place according to the instructions. Calculate also the angle between VQ and the base. VQ and the base. Anytime we are calculating the angle between a line and a plane, we should get the angle between the line and its own projection on the given base. Therefore, we need the angle between VQ and QO, the line between VQ and QO, the angle between VQ and QO, the angle at this point. So the angle between VQ and the base PQRS will be the angle between the line and its projection, which is QO. Therefore, the angle is at this point. That is what we're going to calculate. We got 13 and 10 here. Therefore, we can use a cosine of an angle because this is hypotenuse and this is the adjacent length. Therefore, cosine of theta equals to adjacent of hypotenuse. So cos theta equals to adjacent out of hypotenuse. That means the value of theta will be the cos inverse of 10 over 13. And the value of this angle will be given by 10 over 13. So shift cos 10 over 13 This is going to be 39.72 degrees. So that is the angle. The next is the angle between the plane VQR and the base. VQR and the base. VQR and the base. So these are two planes, VQR, VQR, and the base. Therefore, what we should know is that when two planes are meeting to make an angle, the angle between them is usually, let me show you, is usually the line through one of the planes for example at that point, that is a line through the center of the plane VQR, then through the center of the other plane, we draw another line through the center of the other plane, which is the base. Therefore, through the base at the center there, now we are talking of two planes meeting on line QR. So at QR, we have to establish an angle such that there is a line through the center of one plane, then a line through the center of the other plane. This line is through the center of that plane. Therefore, now there is an angle here. That is the angle between the two planes. That is the angle between the two planes. Therefore, we need the angle. If we let this one to be M, we need the angle VMO. Angle VMO. And remember, we are having the height and we are also having OM as 8 because the total length is 16. Therefore, from O to M should be 8. Therefore, we have this kind of a thing. With this kind of a thing. Sorry. What we are having is M created there. We have O and we have V. Therefore, we need this angle. Remember, we are having this one as 8.3 and this one becomes 8 now. So for us to get the angle at the center there, then we can apply tangent. Yeah, the tangent of the angle is given by opposite out of adjacent length. Therefore, for us to get theta, then we need the tan inverse of 8.3 over 8. And this value can be evaluated as shift tan of 8.3 divided by 8. And this is going to be 46.05 degrees. So that is the angle. We also have another angle here, the angle between VQR and VPS. VQR and VPS. VQR and VPS. These are two planes which are meeting at a vertex. And therefore, let me show you what's happening. So they are meeting at the vertex up there. Therefore, we make again a line from the vertex to the base of the other angle. Therefore, we are having this plane. We are having that plane, and there is also this plane. Now we are saying the two planes are meeting it. We can let this one to be N, such that if we draw a line from the vertex of meeting through the center of this plane we are coming to N, and from the vertex through the center of the other plane, we are coming to M. Therefore, the angle between the two planes now, VPS and VQR, the angle is going to be at the top here. Draw those lines. So VNM, VNM, VNM. So the angle is exactly NVM becomes the angle. So we can extract a triangle through there. The angle at the center there will be the angle between the two planes. Therefore, VMN, and already there is an angle, we have VMN. So we are having a thing like this. VNM. Now that this is O, we are already having this angle as 46 point. Yeah, we have already done here 46.05. This is 46.05. Therefore, the angle NVM will be 46.05 times 2. So when I multiply by 2, I'm having 92, sorry. 92.11 degrees. So that is the angle between the two plates. Thank you so much for following. Subscribe and share.